All right, we've got an IP address, and now the browser can go out there and fetch the page. And I mentioned that this means something. This means, by default, index.html. And what it's going to do is it's going to say, I want to go out to this address. I'm going to pass in this piece of information with this uniform resource locator, and it's going to give me back whatever happens at that end. So chances are pretty good that you go through a proxy on your side, you go out to a router, the router talks to another router, that talks into the frame cloud. Okay, the frame cloud does some magic routing, and somewhere else out of the frame cloud comes, yes, your information to a proxy, probably something like high availability proxy, HA proxy, and that proxy goes out to another proxy, a load distribution proxy, and that proxy goes out to a web server, and the web server is attached to a computer with a file system, and it says, okay, at some location in the file system, like var www, do I have a file named index.html? And if I do, then I'm going to go out here, I'm going to look in my file system, I'm going to say, yes, I have that, I'm going to send it back. It's going to come back up through here, back into the frame cloud, out of the frame cloud, through some routers, through some proxies, and back to you. Wow. Simple. And in the frame cloud, we actually have different disparate networks like AT&T and Sprint and Wiltel. And these guys actually know how to communicate between each other. They have routing tables for that, so they know that this set of addresses goes over here, and between you and this server over here, on average, there are about 14 different systems. So, wow, you've communicated here. You don't even know where this server is. This may not even be one server. They may have these set up so that these are scattered across the country and they're closer to you physically so that it's faster. That's pretty common these days. Now, when it does this, the first thing it's going to do is before it can even get this file, it's going to have to complete this HTTPS handshake. So it does all of this routing stuff, gets its handshake, gets its encryption set up, and boom. Now, if for some reason they didn't have that, instead of getting a file back, you would get a 404 error. And no doubt most of you have used the web enough that you've seen that one time or another, which says, sorry, whatever you were looking for over here, it isn't here. But Washington Post, they'll have an index.html, and they will send it back to you. Now, you go, okay, now it's going to paint Washington Post, the headlines, the menu up here. No. The first thing that happens when the browser gets that file back is it has to take it apart. It has to parse it. It has to look at the headers and see what it got back, what kind of a file. And in this case, we know it's going to be an HTML file. But it's going to take this text file apart, parse it, and it's going to find that it needs some style sheets. That it needs some JavaScript code, that it needs some images, that it needs other resources that it has on there, including stuff for advertising and tracking. Now, some of the style sheets and some of the JavaScript come from Washington Post site, and it now knows the address for that, so it can make those requests and get those back. Others don't. Now, up at the top of the page, there's a little thing that says Washington Post. That's not actually a piece of text. That's actually an image. So this is one of the first things it's going to need to get back, is that image that says the words Washington Post. But when it does the menu and you click on the menu, it actually builds a drop-down box here. That isn't a part of HTML natively. That's done with some JavaScript. And it lays all this page out in the fonts and stuff like that, so it has to get some fonts. And when it lays it out, all of that layout information is in a style sheet. So it's got to go out and get all of these pieces to even start the layout. Now, it used to be that these would happen basically one at a time, and Google looked at this and said, no, this makes the web too slow, And so they invented HTTP 1.2 to speed this up. So these days, chances are that with the Washington Post, and I know this is the case, that when it goes out to get these from this site, from its server, it's going to make one big request and it's going to go, boom, give me all this stuff, and boom, all that stuff comes back. But how many other sites does it access? And if you go and parse the page and look at it, today's Washington Post on the home page accessed 92 different sites. So we're got 91 left to go. And 91 more times, okay, it's going to go out there and say, I've got a domain, I need to resolve this to an address. Okay, I've gone through all the process of address resolution. Okay, now I can go out and I can go someplace else on the web. Someplace else over here. 91 times, just to paint this single page. Now, the people at Washington Post are clever, and the browser will start painting as soon as it's got certain pieces. And they know this, and they know that there is likely a fold, a point at which you can't see. So they have carefully set things up so that this first piece of the page paints in about 1.2 seconds. But to paint the entire page, all the way down to the bottom, takes almost a minute if you're on a fresh system. 54 seconds. To go out there and make all of these requests to all of these things to get all of this stuff. Now, once you've gotten a bunch of this stuff, like the CSS, the JavaScript, some of the images, the tracking stuff, the fonts, and they're all on your computer, it's faster. But that first time you hit the page, it takes a while. It takes almost a minute to pull in all that stuff from all the different sites. And some of these things change frequently, as in every time you refresh the page, that changes. And the advertising, even on the front page of the Washington Post, is 18 different URLs that it's hitting for the advertising. Now, tracking. Washington Post wants to know a whole bunch of different stuff about you, not just how you use the page. They want to know, are you going to click on the options up here and go and read Jennifer's Rubin's column in the opinion pages? Or are you going to click on politics or business? They want to know that stuff. And consequently, they have a whole bunch of tracking, and a bunch of that tracking doesn't even run over HTTPS. It runs over WebSockets. So at the same time that it's doing all this, it's setting up another connection down to its servers over here for tracking. So it does that on WebSockets. So it's setting up additional connections so that when you click on something on the page, it can track that. How long did you look at the front page? Where did you scroll? Did you not scroll? Did you only scroll part way? How frequently are the scrolls? It wants to know a whole bunch of things for a lot of practical reasons, like where is the fold on your computer? How long did it take before you got to see the content? Because those affect how good the quality of the software is. And also, across the WebSockets, it can now push content. Everything up to this point has been a pull, as in the browser has said, I'm going to go out and get stuff. I'm going to go get more stuff. But WebSockets, the server, can actually push content in this direction, which means that sometimes when you bring up the Washington Post, you'll see a second or so later a red headline pop up at the top, and that red headline is pushed from the server. That's new breaking news, and they actually go out and do a push. That comes across WebSockets. That guy, if it shows up, is pushed. So things over here change, that changes. 15 minutes later, something else changes in the country, and they'll push a new headline. So they can actually send stuff to your browser now that the connection is set up. And there's not a lot of difference between this kind of a thing and an application like Slack or Discord. They're both running in a very similar fashion in their browser versions, and we'll talk about how their desktop versions work too. But this kind of a picture with all of these pieces, all of these different things, multiple different languages out here. I don't know that images, depending on what it is, if it's a structured vector graphics image, it's actually a programming language. It's not a bunch of pixels. All the stuff that happens for advertisements, which is iframes and how they're resolved. the different things that happen with tracking with multiple protocols, and then you quite often have fonts. Fonts quite often are also in their own language, using structured vector graphics. All of these different things are happening up here in your browser, but most of these things get to your computer by being a file. They're just a collection of files. It brings it back, and depending on what the file type is, it knows how to handle it and how to paint it. But yeah, it brings back a collection of files, and those files are just chunks of usually text. Some of them are binary like images, but most of them are text files, and you can read them. You can go in your editor and open these files and see what's in them. Now, they may have done things to save bandwidth, like the JavaScript may be compressed. They took out all the blanks out of the program and shrunk it down so that it's smaller. The same thing for the cascading style sheets. But you can still read it, and you can put the blanks back in. There are tools for doing that. So all of these pieces end up on your computer over here. Now, when we get done with this, it eventually renders the whole page. And then you go out and you click on some link on the page. You say, oh, I really do want to read this article right here. There's a headline over there. And you click on that link. And the minute you click on that link, guess what it's going to do? It's going to do all of this stuff all over again, except for the fact that there are a bunch of these things that are now on your computer. So it doesn't have to do as much because it can look locally, and its answer as to where it is closer. But yeah, you click a link, and it does the whole shoot and match again, all over from the beginning. Now, how does this compare to an application? You know, we used to build actual desktop applications. Your browser is a desktop application, and Excel is a desktop application. But lots of things that look like desktop applications these days aren't. They're actually web applications that are masquerading as desktop applications. And there are some good reasons for doing that. But let's break those down and see how they fit in this picture.